8 to just 16. Yeah. No, I want the instantaneous center for this. Okay, now let's see that how you. So what is this? Let me call this a disk. There's a ground. What is the instantaneous center for this? So first we know something velocity of point P. No, we'll calculate velocity of point P. What is the velocity of point P? It should be equal to V, and this is R omega, and the resultant velocity of this is how much? Will be Vp. So what is Vp equal to? V minus R omega. What is V? I assumed 4, R is 0.2, and this is 8. So 4 minus 1.6. How much will get? 2.4. So what is the velocity of point P? It is towards right. So this is having velocity V like this. How much it is? 4 meter per second. What is the velocity of point P? 2.4. Now, can this point P be the instantaneous center? No, when it become instantaneous center? When it becomes, when we equal 0, no, is it? So therefore, and what is omega? Omega about center of mass only. So where the instant center? So what is the method? So what is the method? So we'll go for the general idea. This is a sphere. This is a velocity V, and this is a velocity of point P. Then what I do, I will going to join the tail of velocity vectors and the head of the velocity vectors. This is the instantaneous center. I see I'm writing a instantaneous center. It is the rod. In fact, what happened? It's having instant center outside the rigid body. It's no rule that instant center should be on the rigid body. Now again, a troublesome for you. This instantaneous center, I'll call Y, and this is R. No? So V is equal to R plus Y into omega. Then Vp is equal to Y into omega. Solve for this. We know V omega R everything. So solving that, we'll get the expression for Y. This is what instantaneous center. Now, big trouble for you. What is that? Sir, you are showing in this diagram omega about center of mass. The same omega you are bringing and showing about instant center. I think that's the core idea, no? If you stand on the ground, center of mass moving, and all points are rotating about center of mass. And what is this? This is a forward slipping. How do you can say? How do you can say forward slipping? Look at the velocity of point P. Velocity of point P towards right, no, forward slipping. If the friction were there, okay, it would have acted right. It would have acted left, friction. Then the friction will see that it will increase angular velocity, decrease linear velocity, and finally it will attain pure rolling. Let me call smooth. So no question of friction will act here. Now, what is the basic idea? Instantaneous center means a rigid body. If it is having a forward slipping, the instant center will not be at point P. Will not be the lowest point. Where it will come? It will come somewhere. I'm very controversial statement I'm putting. What is that? Now it's having forward slipping with respect to point P, with respect to ground. It is not having forward slipping if you stand here. This will be really troublesome for you. Here what happened? I don't say any forward slipping, nothing. No, I should not say even pure rolling also, because if I stand at point here instant center, what I feel, the whole rigid body is having only rotating motion. That's all. I should not say pure rolling. I'm not saying any pure rolling. So don't conclude in such a way that here, okay, now sir, forward slipping, here pure rolling. No, here what's happening? Now all points are rotating about instant center with an angular velocity omega. So instant center, so there's a disk, you can take it. So here, yesterday we have discussed, no, you get the velocity of point C, velocity of point P. What is the velocity of point P? We have calculated from here 2.4. So then what will happen? I'll draw a line joining the tail of velocity vectors, head of velocity vector. They'll intersect at a point. That is the instantaneous center. So now whether for a rigid body having forward slipping, it will not have any instantaneous center. No, it will not have instant center at point P. It will have instant center somewhere here. Sir, similarly, what about backward slipping? Can you say anything about backward slipping? Can you draw a diagram on your own? I'm just wanted you to think. Backward slipping, what will happen? The velocity of point P will be towards left. Here, it will come like this. Velocity of point P will come like this. The instant center will come somewhere here. Are you able to think? Pure rolling, it will be here. Backward slipping will be somewhere here. Forward slipping, it will be here. See, for us, instant center is just a mathematical one. For a mechanical engineer, this is the thing which they want. I'll go back to the numerical. Okay, let's see that, how you deal with this question. There's a hollow space, it's not having any mass. Inside that, a rod is kept, mass 1 and length 2r, root 2r. He's asking what is the kinetic energy of the rod at this instant. There's a nice problem I took for discussion. I think we have to hurry up because toppling also I have to wind up today. Okay, I'll start it. Now, what is hollow sphere? You see, it has not given anything, so it's massless. It's a light hollow sphere. Only the rod is having mass. And length is how much? Root 2r. I think that, and what is the radius of this will be r, no? So it will become root 2r length. The sphere is loading on a fixed horizontal surface without slipping with velocity of its center 2v. When the NB is at lowest point, its speed is found to be v, as shown in figure. If the kinetic energy of the rod at this instant is. Okay, now let me get into the question. So here we have a sphere. This is the center of the sphere, no? Now this is a rod. Now what are the velocities? So let's get into this. Let me call O. This is a B. This is A. What is velocity of this end? It is 2v. Velocity of this end is v. Now let's calculate the instant center. Just now I discussed, no? That idea is what you have to apply it. I'll extend this. So why you are doing this? I think there's a general, when you rotate a rigid body, what we notice from that is what I'm taking help of this one. Let me take this is y. Or let me write this is x here. What is 2v is equal to? 2v is equal to r plus x into omega. V is equal to x into omega. So x will become equal to r, solving, and v equal to r omega. So what is omega? V by, what is that omega? Angular velocity of the rod AB about what? About instantaneous center. If you stand here. And where the center of mass of the rod will be here. Let's come. So what is the question asked? Straight away, let's go for it. He's asking the total kinetic energy of the rod. No, this omega, you can do one thing. This omega is what about here? About instant center, all points on the rigid body will rotate with an angular velocity omega. That's what I'm saying. Then if you stand on the ground, then what you are going to comment? All points about center of mass of the system will rotate with an angle of omega, and the center of mass will have translatory motion. That's all, no? So this omega, so if you stand on the ground, you don't see this omega. What you see, all points will rotate about center of mass of system. Where is the center of mass of system? This is a light sphere, massless. So where the center of mass of system will become C. If you stand on the ground, you see that all points on the rod will rotate about center of mass with same omega. This is very important. Now you stand at tension center, then you see that all points on the rod are rotating with angles to omega about tension center. Okay, now how to calculate velocity of center of mass? So here, I'll take help of this mathematics here. This is the point B. Then how the velocity of center of mass should be directed perpendicular to this like a RC. I'll put in this direction. So this is the velocity of center of mass. So what is C? You should write C is the center of mass of rod or system, no? Because the sphere is massless. So let me take this distance. Any symbol we can write. Yeah, only R will write it. I'll write it P. So what is PC is equal to? Let me call R. So we have to now calculate the velocity of center of mass. So what is VC? I should write now. Speed of center of mass. Now I know omega now. I got omega. Now if you stand on the ground, how do it will appear? The whole system. If you stand on the ground, how do this whole system will appear? How do this whole system will appear? This will appear like a, if you stand on the ground, the whole system will appear to rotate with angles to omega about center of mass. So this person, what you will see, I think I'll give one small diagram. Yeah, that one. Yeah. No, tell me like a, what are the things? It will have velocity of center of mass like this, and that omega you have to show here. So what is the kinetic energy of the rod now will be? What you're going to write? Rotational kinetic energy about its center of mass, then translational kinetic energy due to motion of center of mass. So what we have to find out, we know omega. What is IC? What is IC? Moment of inertia about center of mass. This should be equal to m into what is the length of the rod? Will be root 2r whole square by 12. So we know omega. V by r. I have brought it. Somehow, if I can find out the velocity of center of mass, the problem is solved. Able to understand? I think these two diagrams are the core idea. Person standing on the ground. I am seeing it. You will say that I am seeing it. What about here? This person who is there at tension center, he said that I am seeing like this. The two different frames are there. No. How to calculate the velocity of center of mass is the entire our discussion now. We have to calculate the speed of center. For that, we don't know R, no. Somehow, if you can determine small r, problem is solved. Because already we know omega, V by R. Only V C R, small r has to be determined from the geometry. I'll take help. I'll scroll down because I'll draw one more diagram. Yeah, here. So this is sphere. Now this is the rod. Where is the, let's get into this one. So here I'll extend this. So this is the further center of mass here, no? Or the instantaneous center. And there's the velocity of center of mass. I think enough of geometry what we have. We have x, this distance is, what are symbols we took? This is O, no? Yeah. O, A, this is B. X also we got it, the value of X. Now, what can be this angle? 45 degrees. This should be 45 degrees. So let me call this is R1. And let me call this distance S. And this is the center of mass C. And this is P. So what we have to calculate? The PC, where PC equal to R. I think you have enough geometry. Can we find out the value of PC? PC will come if you know this one. PC square is equal to PD whole square plus DC whole square. So PC is what? R square, which is needed. PD is what? We don't know this. So this will be Y plus X whole square. And DC is what? Oh, two things are there, no? Y1, X1. I'm changing symbols because many symbols are there. Y1 plus X whole square plus X1 square. Okay, now take help of all the available data. Now what is AB is equal to? AB is equal to root 2R. So what should be the length? BC should be equal to root 2 or AB by 2 or root 2R by 2. So this will become R by root 2. So now I know BC. If you know BC and you know 45 degrees, you'll get X1 and Y1. After getting X1, Y1, substitute here and we know X, we'll get the R. So let me write R value. Later on you can cross check. It will be R root 5 by 2. So from that, I'll get the velocity of center of mass. So what is the velocity of center of mass should be equal to R into omega. Do we know omega? Yes, we have calculated. No? That you have to substitute here. Can be asked in advanced exam. So I think I gave enough diagrams you can see. Person standing on the ground and person at instant center. That omega is what I'm shifting it here. Why VC should be horizontal? I think it says something very, it is rotating. See, like you stand at point P, it's rotating. You know omega now. Since you know omega, how VC, it's a tangential velocity, how it should be perpendicular to the position vector. If smaller, if this were vertical, then VC would have been horizontal. No, go back to circular motion. Okay, fine. Now I'll go for this value. I think it is given. Value of K is asking, no? 3 it is the value of K is. This will be answer. Do calculations. I'll proceed to the next idea. If the sphere is having a mass, then what happen? Find out the center of mass of system. Then what you should do about center of mass of system, the rod as well as sphere are rotating. Then translational kinetic energy of center of mass plus rotational kinetic energy of the rod and sphere about center of mass. It should be. Okay, next again, the idea like this. A flat rigid body.